Here we go. Our objective for today, I can solve a system of linear equations by graphing. Let's read together. 1, 2, 3. I can solve a system of linear equations by graphing. And if you notice, we're moving on. Okay, we did a little section of data analysis because I wanted to get that before we went to break. But we're now back again on track with our equations. Now, so far we've covered throughout the year, we covered real numbers, expressions, equations in one variable, inequalities in one variable. From there we went to two variable equations and then now we're getting into systems of linear equations. So, what are systems of linear equations? So in your Fourier model, let's find that out. Here it goes. Systems of linear equations are a set of two or more linear equations that have the same variable. A system of linear equations is a set of two or more linear equations that have the same variable. A set of two or more linear equations that have the same variables. Let's see how that looks like. Y equals 3x plus 1 and negative 4x plus 2y equals 6. Negative y equals x minus 5, y equals 2x plus 1. And the last one, negative 6x plus 3y equals 12, and 4x minus 3y equals 8. Copy that. I'll give you guys a little bit of time. Go. All right, here we go. Look up to the screen, please. It says, a system of linear equations is a set of two or more linear equations that have the same variable. So here's one way that they present it, using a bracket. Then they show you y equals 3x plus 1, negative 4x plus 2y equals 6. Since we have 2 here, same variable, this is a system. Look at this next set. Do they use a bracket? No, but since they give you 2 of them, that means it is a system because they have the same variable, same here. Are we there so far? Okay, look at this non-example. Tell your neighbor why that is not a system. Why is that not a system? Everyone. Because it has different variables. They don't have the same variables. That is correct. It's two equations, but this is x and y, and this is a and b. They have to be the same variables. All right, how about this one? Yes? I'm sorry? No, I'm saying they have, both equations need to have the same variables. This one has x, y, and xy, right? Look at this one. This one is x, y, and a, b. Are we there? Okay. Look up. How about this one? Look up. Tell your neighbor why this one is not a system of equations. Because it's only what? One. You need 2 or more. Is that correct? All right, let's get some hashtags here. Here we go. What would clear it up to people about systems of equations? Hannah, hashtag pair. Pair what? Of equations. There you go. How about Matthew? Same variables. And Felipe? Hashtag system. And one more, yeah.
2, and put a plus.
2 plus. And
then equations, because it has to be 2 or more equations. No. Oh, damn.
That's fine, yeah, that'll work. Yeah, I'll take any of those hashtags. Write them down, please. Focus, focus, focus. All right, so usually when we do a lesson, I usually give you the steps as to what we're going to do. Today, you're going to come up with the steps. Yes. So, for right now, copy that, and then we'll get started with example 1. I'm going to pause this really quick. Copy that. Okay, so at the top right of your graphing paper, I want you to write example 1, solve the system by graphing and check your answer. And once again, I'm going to go over this example together with you, and you're going to have to come up with the steps for this process, okay? And think of it like if your BFF is not here, you're going to give him all the info without writing it down, okay? So from memory. So here we go. So we got example 1. Solve the system by graphing. Check your answer. System, y equals 1/3 x minus 3 and 2x plus y equals 4. All right. So we're going to solve it by graphing. So if you have your colored pens, get those out. I'm going to start with red.
Mine's broken, so.
Okay, here we go. Look up to the screen, please. It says, let's graph this first equation. So question, tell your neighbor 3 methods of graphing a linear equation. Tell your neighbor, let them know the 3 methods of graphing linear equation. Okay. Look up, please. Here we go. Look at the first equation. This is already in a certain form, is that correct? And what is this form called? Slope-Intercept form. So in this case, we can actually already start graphing using that form, is that correct? So the first piece of information that I need here is my y-intercept, and everybody, the y-intercept is what? -3. So circle that and plot that point on your y-axis, which is -3, and I'm doing this in red. Okay, there it is. The second piece of information that I need to graph this, I need the slope. What is my slope, everyone? 1/3, which means rise 1 and 3 to the right. Is that correct? So from here I go 1 up, 3 to the right, 1, 2, 3. I plot my point, and I do it again. From that point, 1 up, 1, 2, 3, plot your point, do it again, 1 up, 1, 2, 3, plot your point, graph your line. And remember, the more points you plot, the straighter your line. So with your ruler, I want you to graph that line in red, and make sure it stretches all the way through your coordinate plane, okay?
Yeah, boy.
The ruler on your desk? Okay, then there's some in the back. Thank you. All right. Here it goes. We're done with the first equation. And what was this form called? So tell your neighbor what I need to do to this one so I can start graphing. All right, so here we go. So line down the equal signs, and you guys are saying make it in slope-intercept form. So what do I do here, everyone? Subtract 2x. Subtract 2x. Y equals -2x plus 4. By now, you should know how to graph this. I'll give you a head start. Go. Yeah, graph that line in blue.
What color? Would you do it in red?
I just said in blue.
I know.
Focus, please. Okay. Matthew, help me out. Where do I start for that one? On 4 on the y. So 4y, which is right there. And what is our slope, Matthew? -2 over 1. What does that mean? Go down 2, 1 to the right, plot our point, do it again. 1, 2, 1 to the right, plot our point, do it again. 1, 2, 1 to the right, plot our point, do it again. 1, 2, 1 to the right, plot our point, do it again, 1, 2, 1 to the right, plot your point, graph your line. All right. Once again, make sure you sketch your line all the way through the coordinate plane, okay? All right, now that we have that, talk to your neighbor, let them know what just happened with those two lines. Talk it over, please.
They are affected.
All right. Very good. I heard a lot of people say they intersected. So I want you to plot a green point where they intersected, please. A green point. You can use purple, that's fine. All right, here we go. I'm going to make a big point so that you guys can actually see it. Do you see the point?
Yes.
Okay. And I want you to write the coordinate for that point. Let's write the coordinate for that point. What is the coordinate for that point? 3, -2. That is our solution to the system. Okay? So let me ask a question. What is the solution to the given system? Gio? 3, -2. Why? That's where the equations intersect, okay? What is the solution to that system, Caleb?
The solution to the system is 3, -2.
Why?
The y is -2. Okay. Why is because if you substitute the values, then it'll substitute the values in the equation, then it'll be able to do the same thing.
Okay, close. It says, solve the system by graphing. We just did, and we said that that's the solution. Why?
Because that's where they intersect.
That's where the two lines intersect. Thank you. All right, but not that you guys make a mistake with graphing, but let's say you have someone that you know that makes a mistake with graphing, and they tell you the solution, and they give you a solution point. How can you check to see if that is a solution, the actual solution? So check this out. I'm going to write check right here for my next step. Talk it over to your neighbor. Look at the two equations that they gave us and look at the point that they gave us. Talk it over to your neighbor and let them know what can I do with those two values that they gave me, these two values, and the two equations to check if I got the right solution. I'll give you some time. Go. All right. I heard a lot of substitute the values into the equations. Is that correct? All right, so let's write our equations right here. Y equals 1/3 x minus 3. I'm going to write the other one here. 2x plus y equals 4. And my values, we have an x value and a y value. Is that correct? All right, so my x value here would be 3, and my y value is -2. Bring everything else down. Equals 1/3 times 3 minus 3. So what is 1/3 times 3? 1. Bring down the -3 minus 2. What is 1 minus 3? -2. Is that true? Yes, so it's true. So far, it is true for the first equation. But in order for this to be a solution, it has to be true for both equations. So here we go. So my x value, again, is what? 3. My y value is -2. Bring everything else down. The 2, the plus, equal the 4. What is 2 times 3? 6 plus -2 equals 4. What is 6 plus -2? Is 4 equals 4? Yes, it's true for both. Therefore, that is the solution to the system. Bam. So, let's think about the entire process. Here we go. Look up to the screen. We started with a system of linear equations. Think about the first step. Tell your neighbor, what was the first step to solve the system? What is the first step? Be nice. You got it? All right, let's see. What would be step 1, Lily? Change to slope-intercept form. Step 2. Tell your neighbor the step 2 once you change it to slope-intercept form. Caleb, step 2. Graph the equations. Step 3. Tell your neighbor step 3.
Find the intercept. Find the solution to the system.
Beto.
Find where the intersection.
Find where the lines intersect. And step 4, everyone,
Substitute values.
check your solution. 10Q. Does that make sense? Yeah, right? Now, before I give you an example for you to do by yourself, I'm going to twist your noodle a little bit. Let's see. Yes, I am. Okay, here we go. Writing utensils down. Writing utensils down. Look up to the screen. Here it goes. Look up to the screen. So step 1, I heard, change to slope-intercept form. That would be great for that, in order for everybody to have only one method of graphing and doing that, right? However, look up. That works with this one. That works with this one if we want to do extra work. However, what would be the best way of graphing that equation as it is? Talk it over with your neighbor, please. Malia, what would be the best way to graph that equation? Cover-up method using the x and the y-intercept. Does everybody see that? So as you're working on systems, try to and approach the graphing the fastest way that you can. Does that make sense? So to avoid doing extra work by doing the slope-intercept form and stuff like that, just, 3 different ways of graphing. Just use the method that the best fits, all right? Turn your paper over. Here we go. Do this next one by yourself. Example 2, and it says, solve the system by graphing. Check your answer. System given is y equals x, and y equals negative 2x minus 3. For the first equation, I threw a little curveball to see if you see it. Now, without saying it out loud, whisper to your neighbor. Let them know for the first equation what the y-intercept is and what the slope is for that one. Okay, let's see. Okay, Maya. What was our y-intercept for that first equation? Sure. Axel, what's our y-intercept for this equation? 0 is correct, plus 0. If it doesn't have a constant, then therefore we start at what point? At 0. And tell your neighbor the slope again on this one. 1. Over. 1. Okay, now you have the information. Graph those and find me the solution to that system, please. Copy that and go. All right, here we go. I'm going to get someone to give me the solution. If they got it, we're done. If not, we do one more. Here we go. I got the randomizer going. Let's get, let's see, Jimlet. The solution to this system is one, negative one. What did you forgot something? You switched them? Who got negative one? That is correct. They intersect at this point. Home plate for tonight is on pages 281 and 282 only.
I have an extra.
Have a good one, guys. Enjoy your home play. See you guys tomorrow. Bye.